Hello wonderful person, this is Anton, and in today's video I wanted to answer a very interesting but hypothetical question. What if the smallest discovered black hole so far decided to pass through our solar system or possibly approached our planet Earth relatively close? Let's find out what happens and let's discover what's going to happen to our solar system and to our planet. Welcome to What the Math. So in one of the previous videos, we actually got to visit the smallest black hole discovered so far, known as IGRJ 170913624. I also kind of explained to you how it was very likely created and what's going to happen to this system in the future. But in this video, let's actually assume a hypothetical example where this system actually decides to come close to our solar system and possibly even approaches our planet Earth. And specifically, I'm not really talking about this red dwarf that you see here, which is the partner star for IGRJ, but I'm actually talking about the black hole itself. That's about 3 to maybe 5 masses of the sun, and it's about to swallow this red dwarf, I think. Yep, there you go, it's gone. So, let's assume that this star somehow made it all the way to our solar system, even though it's technically like 28,000 light years away from us right now. Let's assume this is the future, or maybe there's a similar black hole that we haven't discovered yet that is actually on the way to our solar system and is going to basically fly through it at a distance of a few astronomical units away from the sun. We're going to aim right here. I don't know exactly where, but we're going to launch it at a velocity of about 240 kilometers per second, which is actually an approximate speed of our sun around the central black hole in the Milky Way galaxy. And so it's going to be moving relatively fast. And so here it is entering our solar system. And it's actually not very big, and it's close to invisible. It's very, very tiny. It's about 5 kilometers in radius only, 5 masses of the sun. So in comparison to Earth, this would be a very, very small object. This would be basically the size of kind of a large asteroid, kind of maybe similar to the one that killed the dinosaurs 65 million years ago. And it's moving through our solar system really, really fast. So I'm going to accelerate time here. And let's just watch and see what happens to the entire solar system as this 5 masses of sun black hole passes through essentially the central region or the inner solar system. And you can kind of see that most of the planets have already kind of started to divert their orbits. It's actually a little bit easier to see if I look at this from top here, and if I accelerate time from this angle. So you can see the Venus is already stretching away. Earth is kind of moving closer here as well, and there goes that black hole really, really, really fast. And look at that. So Venus gets slingshot maneuver from this approach, and the sun gets kicked out as well. All of the planets basically get thrown out of the system, and I think for the most part this actually will destroy our solar system. Most of the planets that are not captured back by the sun will actually stay in place right there. Like Saturn and Jupiter will actually very likely be orphan planets now. They'll have no parent star. And it's possible that this actually happened in the past. If a star passed by another star, which is actually not a very common event, it's actually kind of rare. But if this happened, the one of the stars might actually fly away, leaving all of the other planets behind, leaving completely empty solar system that doesn't have a sun anymore, or essentially all of these rogue planets that will now just kind of spread through the galaxies by themselves. But as you can see, both Mercury and Earth, and also a few asteroids, are still kind of in orbit around the sun. And Earth actually seems to be, wow, just fine. Okay, no, never mind. It's a little bit hot. It's a little bit toasty. 60 degrees Celsius on average. But nevertheless, it's still around. So what about if this particular black hole approached really close to our planet Earth? Or better even, just for the sakes of making this very beautiful, let's go to a simulation known as Earth and the Moon. And let's assume that this black hole actually decides to capture Earth in its orbit relatively close to itself. So we're going to actually place this black hole in an orbit of about 20,000-ish kilometers here. And so here we go. Here's the black hole in orbit around our planet Earth, although technically it's going to be Earth orbiting the black hole. And it's actually very, very small. It's not very large. You can kind of take Great Pyramid of Giza here for comparison. You can see how small it actually is. So it's just a few kilometers in size. Now, what's going to happen is that right away, our Earth will actually start falling apart. And this is going to happen relatively quick, actually. There you go. Those rocks flew out of Earth really quickly. And this is actually in milliseconds per second. So this is fifth of the actual real time. Now, the reason it's happening is because this tiny black hole, even though its mass is not actually very large, it's exerting a tremendous tidal force on our planet. And the tidal forces here are so strong that chunks of Earth are essentially leaving the planet, making it slowly lose mass. You can actually check out the mass graph here just to see that it's actually going to start losing mass over time. So if I were to accelerate this a little bit faster, you would see that this is actually going to happen with quite a lot of intensity relatively fast. Let's actually change it to, okay, this is almost real time. So this is second per second. Now watch what's going to happen to our planet. So essentially, this is in real time, and this is what you would most likely see if you were to look up into the skies. And actually, let's just stand somewhere that's not destroyed yet, maybe right here. And so here we are on the surface of our planet Earth, and we're going to be looking into the skies and just seeing what we see. I basically press C to stand on the surface, and there's that black hole with all of the chunks of Earth that have now become almost like a ring around our planet. And this is the fire that's created, or I guess the molten Earth that's created by all of the asteroids that do fall back to the planet, and also the tidal forces that essentially heat up the planet from the inside. Now let's run this for maybe a few minutes, and just so you can actually see what's going to happen to our planet eventually. And also, don't forget that somewhere nearby, there is also our companion, the moon. There it is. And as you can imagine, the moon is actually also coming this way, and at some point is going to approach our planet Earth, and very likely either collide with the black hole or collide with Earth. And so I'm going to run this just for fun, just to see what all of this turns into, because right now our planet is just being shredded. Essentially, the equator here is being bombarded with tremendous amounts of its own matter, so basically Earth particles. And the rest of the planet seems to be, it looks okay, but it's really not. Tremendous tsunamis, earthquakes, huge tidal forces that will probably rip everyone apart. And at this point, everyone is essentially dead. But the planet is still kicking. It's still kind of round. It's still spherical. It is getting hot, though. It's getting really, really, really hot. Anyway, we're going to run this and observe what happens. And most of our planet is now covered in the molten part of the surface. And you can kind of see that even the moon started to slowly fall apart because of the tidal forces that are generated by the black hole. This is actually what it looks like from a distance here. And we're going to observe our approach from this angle for a little bit. But you can see that even the moon particles are striking back at the moon and ripping itself apart. And so here goes nothing. Here comes the big collision between the Earth and the moon, or possibly the black hole and the moon. And this is going to be very likely very, very beautiful. So here we go. Ready? And let's slow down time here. And here it is. And it just kind of disappeared. Interesting. Alright, so that's basically a moon being sucked into the black hole and disappearing completely. Now, if I were to run this continuously for many hours, what you would eventually see is that, well, first of all, our Earth is going to start evaporating and create a very beautiful, very fiery looking accretion disk around IGRJ 1709. And I think I'm going to run this for maybe a few more in-game minutes just to show you what it's going to look like later on. And so there go those fiery particles, creating a very beautiful, very alarmingly looking and very interesting looking accretion disk. There's actually even a fragment that became its own moon. 13 masses of the moon. And all of this is coming from Earth. Earth is essentially falling apart. It's already under 3 masses of the moon, and it's creating these huge particles and also a lot of other really interesting special effects. And so essentially that's what would happen if the smallest black hole in our galaxy actually orbited or came close to our planet Earth. And look at what this game is doing to all of these crazy particles. It's creating its own system, its own planetary system around itself. And all of this is created from our beautiful planet Earth that's slowly losing more and more mass. And well, it didn't take long to create something absolutely marvelous and incredible looking. So there you go. This is actually what I was trying to create this whole time. A very beautiful, very unusual looking accretion disk made entirely out of our planet Earth. And hopefully this is something that you enjoyed watching, and if you did, don't forget to subscribe. And you know what, consider coming back here tomorrow because you might learn something completely different about space, sciences, or math. And anyway, I'll see you guys in the next video. Space out, and consider maybe supporting this channel on Patreon too, because, you know, it does help me make better videos. But anyway, thank you so much for all of your support, guys. I appreciate all of your help, and I really enjoy making these videos, so all of your comments make my life so much happier. Thank you. I'll see you in the next video. Bye-bye. And I'm just going to accelerate this even more, just to see what this whole thing turns into in the next few seconds.